Welcome ninth grade extended students. Today we are going to talk about proportionality theorems. So first we need to talk about what it means to divide sides proportionally, and you can later read through this if you'd like, but if I have a segment drawn in this triangle and it divides my sides proportionally, it would mean that AD, comma DB, this distance with this distance is proportional to AE, EC. So AD compares to DB as AE compares to EC. They are all in the same ratio. We can also talk about the legs of this trapezoid being divided proportionally if the ordered pair PU, comma US is proportional to QV, comma VR. So top, comma bottom is proportional to top, comma bottom. Same kind of idea over here. Top, comma bottom is proportional to top, comma bottom. So if I say a segment divides the sides proportionally, that's what I mean. So here comes our first triangle proportionality theorem. So as I look at this triangle, I have side ED or segment ED parallel to segment BC. So it says this. I have my triangle ABC. D is the point between A and B, and E is a point between E and C. Then the line DE divides the sides AB and AC proportionally if and only if DE is parallel to BC. So if this is parallel to that, it would divide the sides proportionally. And I could set up a proportion that says DE is to BC as AD is to AB. So it's really telling us two things. First, by saying that my segment divides those sides proportionally, it's saying that I could write a proportion that says AE over EC equals AD over DB. So top is to bottom as top is to bottom. But further, it tells us something about these segments as well. DE over BC is equal to AD over AB. Inside over outside as inside over outside. And furthermore, I could say that this is equal to AE over AC, since they're in the same ratio. So let's do an example involving that. And if you studied honors geometry, they would call this the side splitter theorem. So if you have a segment that's parallel to the opposite side of your triangle, it divides the sides proportionally. So if I'm given that BE is parallel to CD, I want to find ED here, and I'd also like to find CD. So I'm looking for ED and CD. So set up some proportions and solve. Press pause on your video. When you're ready for the answer, press play again. So here are the proportions. AB over BC equals AE over ED. Substituting in the values, I have 4 over 2 equals 7 over x. I can cross multiply. Here I simplified. 4 over 2 is the same as 2 over 1. Cross multiply, 2x equals 7. X must be 3.5 or 7 over 2. Part B, I'm looking for this opposite side y. So I know that AB, inside over part over whole, inside over outside, inside triangle, outside triangle. So AB over AC equals BE over CD, which is y. So I substitute in my values, and I get 2 over 3 equals 6 over y. Cross multiply and solve, y is 9. Another theorem is a corollary to the triangle proportionality theorem, and it involves something called a mid-segment. And a mid-segment is a segment whose endpoints are on the midpoints of two sides of my triangle. So I have my mid-segment drawn there. So let's see what the theorem says about the mid-segment. So if I consider this triangle ABC, let me see if I should label it A, B, C. I'm going to let D be the midpoint of AB and E be the midpoint of AC. Then DE is parallel to BC. This would be parallel to that. And DE is half the opposite side. So again, if I have a mid-segment, meaning I have a segment with endpoints on the midpoints of two sides of my triangle, that segment is half the length of the opposite side, and further, this segment is parallel to the opposite side. So let's look at this example. I'd like to find EC. You'll notice IJ is the mid-segment. So set up your proportions, solve for X, find the segment length, press pause on the video, and when you're ready for the answer again, press play. So here's my answer. I know that my mid-segment, x plus 16, has to be equal to half the opposite side, 1/2 the quantity x plus 26. I multiplied both sides of my equation by 2 so that I didn't have to deal with that fraction, and then I solved for x. I subtracted x from both sides and subtracted 32 from both sides. You'll notice x is negative. Now, while a side length cannot be negative, a variable can be. So I now know x is -6. I wanted to find EC. EC is x plus 26. So substituting in, I find that EC is 20. So if I had come up with a value x that made my side length negative, I would have said no solution. Here's the trapezoidal proportionality theorem. It's very similar to the triangle proportionality theorem. By the way, the proof of this is in exercise 178. It's installed for your reading pleasure. If you consider this trapezoid PQRS, in which you have PQ parallel to RS, it's just defining what the bases are, and I let U be a point between P and S, and V be a point between Q and R over here, just the way I have it drawn. The line UV divides the legs PS and QR proportionally if and only if this line is parallel to that line. Furthermore, when the division is proportional, I can find the length of this segment this way. So a little bit confusing of a formula, but let's see if I can make some sense over it. As I'm looking for the length of UB, I take the ratio, A divided by the sum, this part divided by the sum, times my base. So this part is away from this base. This part divided by the whole times the base that's away from this part, plus 1 minus that ratio times the other base. And that way I can find the length of that segment. Further, when I have this segment parallel to that, it divides the legs proportionally, meaning I can take bottom divided by top, that's equal to bottom divided by top. So why don't you try this example? Press pause on your video, and when you're ready for the answer, press play again. Here's my answer. I used my formula. I did 2 divided by the whole, 2 over 6 times the 10, because the 10 is the base that's further away from the 2, plus 1 minus that ratio times the other base, 12. And when I calculate, I find that my segment length is 34 over 3. Now, just to show you that works either way, I did it in the reverse order. So I did 4 over this whole, so 4 over 6, times the base that's further away, 12, plus 1 minus the ratio times 10, and you get the same thing, 34 over 3. Here's a corollary to the trapezoid proportionality theorem. Corollary just means that it takes that proportionality theorem and it extends it to a special case. Now, the midsegment of a trapezoid is similar to the midsegment of a triangle in that it is the segment that has endpoints that are the midpoints of the legs, or the non-parallel sides. Now, the trapezoid midsegment theorem says if I have a trapezoid where I have PQ parallel to RS, so it's just specifying what the bases are, and U is the midpoint of PS and V is the midpoint of QR, then I know that this midsegment is parallel to the bases, and I also know that the midsegment is half the sum of the bases. So here's an example where I'd like you to use the corollary to the trapezoid proportionality theorem. Press pause on your video, solve for X, find the segment length CD. When you're ready for the answers, press play again. Okay, so the answer to how long is CD is 11. This is how I found it. So I said my midsegment, 4x minus 33, is equal to half the sum of my bases. I simplified and solved for x. You'll notice x is 11. It was not asking me for x, it was asking me for the length CD. And it just so happens that when I plug into 4x minus 33, I get 44 minus 33, and that's 11. So the side length is the same as the variable value, but that does not always happen, and in fact usually does not. Here is another theorem that involving parallel lines, in fact 3 parallel lines and 2 transversals. So if I have 3 or more parallel lines that are intersected by 2 transversals, then the parallel lines divide the transversals proportionally. So you can see a picture drawn here. I have 3 parallel lines, and I have 2 transversals here and here. And if that's the case, it's going to divide these transversals proportionally. In other words, I know that AC divided by CE has to equal BD divided by DF. Top over bottom equals top over bottom. Here's an example. I'd like you to set up a proportion and solve for X. Press pause on your video, and when you're ready for the answer, press play again. Okay, so here is my answer. You'll notice I know these 3 lines are parallel, so it divides these segments proportionally. So I did 20 over 25 equals 8 over, let's try that again. 20 over 25 equals this sum here over this sum here. So 20 over 25 equals 28 over 4x plus 11. Solve this for x, you'll find that x is 6. Finally, an angle bisector theorem. This has to do with a triangle and an angle bisector of that triangle, just like that. If a ray bisects an angle of a triangle, then it divides the opposite side into segments that are proportional to the adjacent sides. So looking at this triangle, I have an angle bisector there. It's dividing my opposite side in the same proportion as the adjacent sides. So A over B equals C over D. And it's all about following a pattern. A over B, C over D. Top over bottom equals top over bottom. I could also write A over C equals B over D. Left is to right as left is to right. Here's an example. We're given that angle RVS is congruent to SVT. In other words, I'm looking at an angle bisector. I'd like you to find the length of ST. Set up a proportion and solve. Press pause on your video, and when you're ready for the answer, press play again. Okay, here's my answer. I have VR over VT, VR over VT equals RS over ST. Left is to right as left is to right. Substitute in my values, cross multiply, and solve. So ST is equal to 5. I have put some practice online for you, so work on that. It involves all of these different theorems we've learned today. Have a great day.